Broadcasting from Studio 202 at the Springett Technology Center in Navasota, Texas, it's NOV Live. Now, let's start the show.
Hello and welcome to NOV Live. My name is Shelby Dumaine and I'm your host this morning. This is the show where we talk to experts from here at NOV and we bring their knowledge out to you, our audience. So thank you so much for joining us. As the intro said, we are live right now here from Navasota, Texas in Studio 202. So thank you for joining us this morning wherever you're tuning in from. Before we get into the interview of the show, we have some incredible guests. We're going to be talking about robotics. We're very excited. I wanted to introduce a new face to the show. We have our summer intern, Christian Hay. Good morning, Christian.
Thank you, Shelby. I appreciate it.
Absolutely.
Anybody watching out there, we'd love to hear where you're watching from. Just drop that down in the chat for us. In the chat as well, if you have any questions for our panel of experts here on robotics, just let us know there in the chat as well, and we'll try to get to some of those questions at the end of the show. Speaking of questions, today's trivia question is, what was the name of the first robot ever invented, and where was it used? What was it used for? Do you think you have the answer for that? Just let us know in the chat, and we'll come back to that at the end of the show. Shelby, that's all I got. Back to you.
All right. Thank you very much, Christian. All right. So we're super excited. I love that trivia question, by the way. So we're asking, kind of a general throwback in the history of robotics in general, which leads us into our topic for today. So we're going to be talking about robotics with probably two of our best experts on robotics here at NOV. We have Justin Kinney and David Moon. So welcome to the show. First off, thank you for joining. Absolutely. And just to kick it off, when I was getting the show ready today and talking to y'all, and I took a look at your titles, and both of y'all, pretty hefty titles. We have lower thirds, so we'll show them in a minute, but it's Senior Technical Managers for Robotics and Mechatronics Engineering. So can you tell me, what is that? What do you do here at NOV? We'll start with you, Justin. What does that mean? What do you do?
Okay, well, it sort of started off, we were all just engineers, right? So I think manager got added to that title, but we were robotics, mechatronics engineers. Basically, what I do, we've broken the team up into sort of three parts. We've got deployment and we've got development, and there's a reason for that, right? So we've developed a solution, we've got the MVP, it's out there, but we've got to deploy this on our customer's rig. So what my team's main focus on is making sure that it gets on the customer's rig, we support the FATs, we support the commissioning, and then it's installed and it works. The reason that's important is because if we just focused on deployment all the time, which we're hoping that's going to happen, right, we're not going to do our development like we need to do. So what everybody's seeing, that's really just the tip of the iceberg, right? So David's team, there's another small team in Norway. They work on development, and he'll talk a little bit about that.
Yeah.
Yes. So I'm again Senior Technical Manager of Robotics and Mechatronics Engineering, which is quite a hefty long title. So if I just talk a little bit about myself, then I joined NOV a little shy of 4 years ago as the first hire of this group. Robotics and mechatronics engineer at that moment. So being the first employee or being the first member of the group, I was really lucky to be involved and see all the cool stuff developed so far, which made the current Atom RTX system that we try to push out to the market right now. So for now, as Justin mentioned, I'm leading a new product development effort within this robotics group in the Western Hemisphere region.
That's awesome. So 4 years ago, I just hit my 4 years, so it sounds like we might have started here at NOV right around the same time.
Probably.
I feel like we're in the same class. Yeah. And I wanted to real quick ask you, so you said MVP. Anytime I hear an acronym, am I right, is that most valuable player, or does that stand for something else?
Minimum viable product. So basically what's out there now, what we're showing, and it's on all the social media and stuff, it's tailing, doping, mud containment, land and offshore. applications. So that's
Okay.
minimum. That's what we got out there. That's what's working. But again, there's a lot in the pipeline. We can't probably go into a lot of the details, but we're working on the things that people need now.
Man, I'm always trying to test my acronym, so I'm like, man, I got another one wrong. But I'm always learning.
It's
So
close.
that's the key
It's
part.
close.
But speaking of that MVP, so I wanted to ask y'all also, you know, the topic, the title of the show is the journey from testing to operating for robotics. So can you talk to that journey a little bit and tell us about it?
Well, we started to dream about the fully automated and hands-free drill floor, which is a big
Yeah.
dream, right? And then when we actually first gathered the group and start to work on this actual project, we thought about the what can be automated first. Obviously, drill pipe on the floor was the most obvious object that can be handled by robotics or automation, going through the automation. So we started to look at the designing the system, not building the single equipment that is equivalent to the robotic arm or some type of the robotic system. So try to develop the entire system that enables the fully hands-free drill floor from the beginning. So the core value and the philosophy of the whole system design was one of the core value was the modularity of the whole system. So we were meticulously design the system component by component. Everything can be like in experts' term, it's more like object-oriented way. So you don't need to build from the scratch every time you deploy the system.
Right.
So for component by component, it's object-oriented way designed so that it's gonna become a building block of the entire system later down the road. So at the beginning, what we could see, as I mentioned before, was just robotic arm that may handle the drill pipe on the floor, right?
Right.
So we started to look at the human behavior, how human handled the pipe on the floor and on the monkey board, especially here at the STC. At that moment, it was RDTC. So we just closely observe how recruits handle the pipe. From there, we got an idea that maybe we don't need to design the equipment, heavy equipment, like we usually do from the scratch. Just by having a commoditized, off-the-shelf robot, and then making a system built around it, then probably we can make a very fast-paced, developed solution, provided to the client in a short amount of time. So that was the starting point, and as I mentioned, since the tailing pipe was our first focus, so for the externally at that moment, we were looking for a robot manufacturer or OEM that we can partner with. That was one huge branch that we actually had put much effort on it, and the internally. I was first hired, and then later down the road, we grew our team, but nobody was the real robotics engineer at that moment. So we just taught ourselves, to being a robotics engineer. We got a lot of help from the outside institutes, and just to be. Learning to be a robotics engineer was, biggest part that we actually had to do internally as well.
Right. So that's really interesting. So, because we talked a little bit about what y'all do now, but what does that mean? It sounds like you almost had to create what being a robotics engineer means. So what would y'all say that means to you, being a robotics engineer?
So that's a really interesting question. We get asked that a lot. I was just at a conference a couple weeks ago, and I was in a room with robotics engineers, and they couldn't answer. Some of them couldn't answer that question. So
Yeah.
we, like David said, we started off on this journey, and I had the privilege of working with very intelligent people to do this. We couldn't have done it without all of them. But we were very good at what we had focused on our entire careers, whether that was mechanical engineering, electrical engineering, software engineering, experience with rigs. we all had our focus and our biases, if you will. But what we very quickly found out is to be a robotics engineer, we needed 3 core disciplines: electrical, mechanical, and software, to actually bring all that stuff together. So what we all had to do is we had to learn how to do the things that we weren't necessarily naturally good at or trained at or whatever. So over the course of, I don't know, almost 4 years, we became robotics engineers. We started to understand what it meant to be a robotics engineer, and I think we helped define that for our industry and even outside in the robotics community.
Absolutely. And so once you kind of did the research and started, like you said, figuring out what that means base level to be a robotics engineer, what came next in the process? What did you go from there?
So, as David said, we sort of had like a high-level guidance from our management. They said, I think there was an animation, which animations are really good, but they're really dangerous as well when we're told make that happen. So we had to figure out how to make that animation happen, and there was a lot of details that we had to figure out. So we started to figure out how to tail pipe. That was the first thing we did on the test rig here. It was a fully manual rig, and we put a robot on it, and we moved pipe around to see if all of our calculations actually were right. Because that's the tricky part, is right. You do all these calculations, you go, oh, this robot should be fine. Well, we pushed it to its limits. We realized that there was no pipe on the drill floor that the robot couldn't tail, couldn't handle. So basically, if a human could do it, the robot could do it. So that was the first thing, is we figured out that was possible. So then we moved on and we figured out, okay, well, what robots do we really want to use? So we chose the robots. We put a lower robot on the drill floor, permanent install on this rig. And we started tailing pipe at the bottom. So really, we took a bunch of people off the drill floor really quick in our development. And then pretty soon after that, I want to say maybe 9 months later, we were laying the rig down, changing out the fingerboard, putting a new fingerboard on with an upper robot. And at that point, it was a roboticized rig. We were missing ancillary tasks, but we'll get to that. I think David's going to talk a little bit about the testing of the upper robot and sort of how that transitioned into the deepest well on site. I think it's well 70.
Wow.
So.
Absolutely.
Yeah, so as Justin mentioned, and now you can actually see from the screen there, that's the lower tailing arm. That's the first system that we commissioned to the STC prime rig, test rig. It has its unique challenge by having, a track at the bottom of it. It has more than 6-degree freedom, which is typical, degree freedom of the robotic arm. So path planning of the 7-degree freedom of arm was a unique challenge for the lower arm. And then, as I mentioned, from the beginning, we were actually building the block, right? So since as a guy software centric, I started I started to building the path planning block and control block of the lower tailing arm, which is 7-degree freedom, and then when it was a time to develop the similar function up on the fingerboard for the 6-degree freedom arm, what can go wrong, right? So I already have all the building blocks, so it's gonna be really easy and a piece of cake. That was my mindset at that moment. But once we modify all the fingerboard and installed, lay down the rig and install that, that was a huge work. Everybody was just hell into it and do all the manual jobs, and it finally happened. And then when it was ready to be commissioned as a system, implement the software, now there was a little hiccup there. So I found that the upper tailing seems very similar to the lower tailing, but was really, really different. So I had to almost, write up the code almost from the scratch, about like 50% of the code. Wow. In a very short amount of time with high pressure that everybody was like looking at me and like, when it's going to be ready, when it's going to be ready. So yeah, so it was tough, but really fun as well. So yeah, every robot we deployed and commissioned on the STC Prime rig was the first of its kind. So every one of them had its own, unique challenges. We kind of enjoyed that, and also like we struggled a lot.
Yeah.
Yeah, one of the examples that I can, talk about, especially about the upper arm, was so as a software-centric guy, like, everything that I can think of during the software coding is about the things happening in the ideal world, right?
Right.
So there is a virtual space and environment that's representing the actual rig environment.
Wow.
And I'm doing the coding and path planning within that ideal environment. So everything is perfect. Pipe is really, straight and rigid. Everything is really perfect in that word. So I planned, I coded the path planning code in there and planned the path. And when we're trying to implement there in the, actual rig, we realized that the pipe location, the actual position of the pipe was not near where it's supposed to be in the ideal world. So like if you think about the fingerboard, then since it's land rig, we don't have the latches like the offshore fingerboard. So like pipes are just like lean each other. So in the ideal world, they are perfectly lined up within the finger, and then every pipe is aligned joint by tool joint by tool joint. The clearance between pipes are exactly the same, but in real world, it's just overlapping each other, and then like just because of that, pre-planned path didn't actually work.
Right.
So that was a major hurdle we had, and then we come up with the really a quick solution, both in software and also the mechanical perspective. The one that you can see from that screen is called the spacer system. One of our lead mechanical designer, Chris Saunders, came up with a really cool idea. It's not latch, but passive spacer system. So with a very, relatively cheaper cost, it can space out the, pipe as close to, ideal world that I, program the robot to move. So that was really interesting, one of the challenges we faced with.
Right.
Yeah, and the rest of the other challenges, maybe Justin have some idea?
Yeah, just a couple things to point out in what David was talking about. We did all that in 2 weeks.
Wow.
So we
Was crazy.
fixed all the code, designed the spacers, manufactured the spacers, commissioned everything. Every day was fun. And then they went and drilled well 70 with minimal downtime.
Wow.
So that was, I thought that was impressive. And again, David talks about building blocks. I don't think, if we didn't have any of those building blocks in place and start growing them, mechanical, electrical, software, we wouldn't have been able to do it. The other thing that I want to point out is we're talking a lot about land rigs. We're showing a lot of stuff about land rigs because we're at STC. This system isn't a land system. This is just what we have to work with here. But everything that we've done can go offshore. It can do the same thing offshore that it does on land. And that was part of that design concept. The other thing that I don't think we've mentioned, and we haven't seen a lot of it, it's really important. I think it's not to minimize all the other efforts of all the other things we've done, but we have this quick disconnect technology, which, in my opinion, that's pivotal to what we do. It's what enables the RTX robot to be a true transport mechanism. We didn't design a tool to do one thing. So it can come in, and I think we did show some of those videos up there, but the tool can come in and go, okay, I'm a doper head now. Well, now I'm going to be a mud bucket. And a person doesn't have to go outside. He doesn't have to pick up tools and change the head. You can do that all from the driller's cabin based on the task that you're doing, just with some clicks of a button.
Wow, that's incredible. I think, talking about the perfect world versus imperfect world, and how do those, how can we change both the real world to be more perfect, like with the spacers, but also, kind of compromise there with both is such an incredible story. And I also know when I was looking at, kind of preparing for this show and seeing that you'll also have to take into consideration what human behavior is and how does that play into how a robot functions. I think we forget how maybe elegant and also clumsy at the same time real life humans can be. So
Really elegant.
yeah, turning that into a robot, I can't imagine kind of
And I
difficulty
think
there.
sometimes what we do is we overcomplicate things because we sit in our cube or we sit in our office and we go, I'm going to make it do this, right? And all we had to do is go outside and look at what the people are doing. Because they give us so many hints, right? They're subtle behaviors, they're intentional behaviors. And sometimes these problems that we'd be banging our head on the wall for like a month or more, we just walk up on the rig and either talk to somebody or watch somebody and go, okay, this is a lot easier than we thought. So.
Wow, absolutely. And I think we talked a lot about already what it's designed to do, talking about land and offshore. Is there anything else that we missed, or was that, did we pretty much cover it?
Well, there's more to come. We can't really talk about the more to come, but every time we've had visitors out here, and we continue to have visitors out here, they ask us, well, what about this? What about this? What about this? And before those questions were even asked, we're working on those things.
Absolutely.
So, and I think we're also working on those things in the same agile and rapid way that we've done the MVP, or minimum viable product. So,
Absolutely. And I think you bring up a good point that we'll talk about a little bit, how people can reach out and contact us. But I think that's a good way, is people actually coming out here and visiting. I mean, we talk about STC a lot. We've done a couple of shows on this facility itself. But I definitely invite, if anyone's watching and wants to see this. I know I've seen the robot I've gone up on the test rig, and I think I've probably made some engineers roll their eyes because I'm like, it's so cute. Look at it go.
we've had some cute names for it over the past few years. I don't think we talk about the importance of this place enough. Without STC and without the ability to do stuff in our lab, we have a robotics lab here, and then iterate to the rig and back to the lab, we probably wouldn't have been able to do things as quickly as we could. So this place is, I think, key to development for us. I think it can be key for other developments as well.
Right.
It's a very
People
important
come
place.
check it out. Absolutely. Well, I want to make sure I give time for our audience to get any of their questions asked. So I'm going to throw it back over to Christian. You got any questions for the guys here?
I do indeed. The first one is, how does the robotics system require a new build? Like, what is it on a new build? What is it? Sorry.
Like, is it for like a new rig or to install it on a existing rig?
To install it, yes, sir.
So, again, it's layout dependent. We've focused on our designs, but we've looked at a lot of other rig designs as well. We need space. It doesn't take that much space, which I think, again, that's what makes it unique and modular, is we can take a pretty small footprint and fit the robots that you need to do to remove the people from the red zone.
So does that affect any of the equipment on the drill floor that's normally operated by hand?
So the system can operate without changing your other equipment. It's more optimal if you upgrade certain things. I'll have some examples where a lot of roughnecks on land rigs have the hydraulic handles. This system can work with that, right? You won't get the same KPIs, you won't get the same efficiencies, but it is possible. So it's not required to upgrade everything to put robots on your rig.
And then lastly, after it is installed on the rig, what does the maintenance look like on it?
So the maintenance is very similar to a lot of our other equipment. There's daily stuff, there's yearly stuff, major overhauls over 5 years, stuff like that. So it's nothing abnormal to what our customers are used to with our other equipment.
Typical. Yeah. Excellent. Thank you, Christian. And before we close out the show and everything, I want to see, can you give us the answer on that trivia question? First, repeat the question for any last minute, maybe people who want to try to type it in real quick, but can you give us that?
For sure. The question was, what was the name of the first robot ever invented in the world, and what was it used for? It's called Unimate, and it was implemented by GM to move hot metal so that people didn't burn themselves.
Nice. And I think I looked into that too, and I think it was like 1961 or 62, so kind of coming up, or I just had an anniversary of that first ever robot to exist. That's really great. And before we end, I do also want to say, everyone throw in the comments, congrats Christian for his first show. So thank you very much. And back to y'all. Thank y'all so much for coming. I think this is such an incredible product. Is there a way folks can contact y'all? Is there an email or website or anything? I think we might have had one. Let me see. Robotics@NOV.com.
That one.
Look how simple.
I should have known that. Makes sense.
I just do.
Yeah.
Well, luckily it'll be easy to remember. If you liked the robotics show, you check out robotics@NOV.com. I'm sure you could come. We could see about getting a visit out here to see it. But thank you both so much for coming on the show. I think this was really incredible information.
Thank you for having us.
Absolutely. Well, for everybody who tuned in today, thank you so much for watching. We want to thank, of course, our guests today, our social media chair, Christian over there, as well as our production team, Paul Dufio, Wei Han Lin, and Ben Lasher today. So thank you so much for joining, and we will see you next time.